Welcome to SysEng Quick. My name is John, and today we're going to use Ansible to interact with the HashiCorp Vault instance we set up in the previous video. After all, why go to all the trouble of setting it up and then not even use it? I expect this to be the final video for this Ansible project. If you've found the content helpful, I'd really appreciate it if you clicked on those like and subscribe buttons. It really helps out the channel. Okay, let's get started. In VS Code, I've got the galaxy.yaml file open for our collection. There is a community collection we can install to work with HashiCorp Vault. So let's go ahead and install that. We'll go to the command line and do Ansible Galaxy collection install community.hashi_vault. It's going to install version 6.2.0. So let's go ahead and add that to our Galaxy dependencies list. I'll go ahead and copy this, and we'll go back to our file, and we'll say this is the version we want, and we'll just say we need at least this version, and we're going to want less than the next version. Okay, that looks pretty good, I think. We also need to install the HVAC Python library to work with the collection. So let's do that as well. We'll go ahead and do poetry add HVAC. Okay, we should have everything we need to work with the collection now. One more tool we might want to get is the HashiCorp Vault CLI interface. We can do that by pulling it down from their website. I've added this curl command to install it in our dev container. Let's go rebuild the Docker image and then use that to rebuild our dev container. If you are concerned you don't have the latest version of the dev container, simply run docker pull and then the image tag, ghcr.io, the GitHub container registry, SysEng Quick YouTube, Ansible : latest. And then once you do this, it will pull down the latest image from the GitHub container registry. Once you have the latest image, in VS Code, open the command palette with Ctrl-Shift-P, or on a Mac, Command-Shift-P, and then do rebuild dev container image. But I don't want the latest image from GitHub's public registry because I haven't pushed our changes yet. I need to rebuild our existing image locally. So I want to do docker build -t, and then I'll give it that tag, and then I'll give it the file of dev container docker file, and give it the context of the current directory. Now that the container image is rebuilt, I can rebuild my dev container. Back in VS Code, I'll open the command palette with Ctrl-Shift-P, and I'm going to say rebuild and reopen in dev container. Let's see if we can use the Vault CLI now that we've rebuilt our dev container. I'll go to the terminal and type vault status. Well, we do have Vault CLI, but we can't access our vault. It's not looking in the right place. The default location is not where our vault instance lives. So let's edit our bashrc file in the user's home directory. I'm going to use vim for this. And I'll say export vault_adder equals HTTP, not S, but we will be fixing that before the end of the episode. And I want to put that at vault localhoplaza.net :A200. That is where my vault instance is living. Let's go ahead and save that file, and I will make a new terminal to source that information. Now, if I do a vault status, yes, we are able to access our vault. So I'm going to need to log in and get a token so that we can access information in the vault. Between episodes, I did set up a secret key value store, and I added GitHub authentication. So let's go ahead and do that. We're going to do vault login method equals GitHub. Let me go grab my token. And now that I've pasted my token in, we now have a new HashiCorp Vault token. And that should enable us access to the secret vault, but basically nowhere else. So it's not my root token, and I can revoke it later on. But for now, this should be fine. Let's see if I can access any secrets. If I do vault kv list secret. I do have a key for Proxmox. So let's try vault kv get secret Proxmox. And there we go. We have some information in there. We need to update this, but it's a good start. We do have access to set secrets. Let's see if we can use Ansible to get the same information we got on the CLI. Let's set up a new playbook. I'm going to call this vault-test.yaml, and we'll call the play test HashiCorp Vault with Ansible. We're going to run this against the local host, and we don't need to gather any facts. I'll set that to false. For our first task, I want to fetch that Proxmox secret we got from the command line. So let's fetch Proxmox secret from Vault. And to do that, we're going to use the Vault kv2 get module. This is from the community Hashi Vault that we installed earlier. We need to supply it the path to our secret. This is going to be Proxmox, in other words, the name of our secret. I called my kv2 store secret, so I'm fine with the defaults. But if you have a different kv2 store, you can use engine mount point, specify that instead. So maybe you called it kv2, but I didn't. I called it secret. Secret/Proxmox is the full path to that. But this is the default engine mount point. We don't need to specify it. So I'll go ahead and kill that. Then we need to use register to save the result of our fetch. And let's go ahead and display the outcome. Display Proxmox secret, and we'll use the debug module. The var is going to be the result. Let's go to the CLI and see if this works. When we go over there, we can run Ansible playbook, syseng quick, turiel, vault_test. And there we go, we have fetched our secret. And you can see it gives us a lot of information. Now this result, that's our variable. A lot of this is related to the outcome of the module we just ran, but some of it is related to specifically HashiCorp Vault. So changed and failed, these are part of basically every result you get back. But data, metadata, this is the data we got fetched from HashiCorp Vault. And it supplies it in a few ways. So you can see data and metadata is repeated in a few places, but just use whichever one is useful to you. I'm not really sure what the difference between raw and non-raw is, but I don't know. It's fine. Mostly, you're going to be interested in secret. That's the actual key values that are in the dictionary you store here. As you can see, all we have is the user root@pam. Reading our existing secret went pretty well. Are we able to write things to our vault as well? Let's find out. Let's update our Proxmox secret. What if we want to add the root token? So let's add root token to our Proxmox secret. So for this, we're going to use the vault kv2 write module. And again, we're going to give it the path as Proxmox, and then we give it the data we want to write here. So let's say root token, or maybe just token, and I don't know what it is, so I'm going to put garbage in there for now. And let's see if that works. Let's go ahead and save this and run the module again. We'll go ahead and clear the screen and run vault test. It changed things, and now we have our token in here. But there's a problem. What happened to our root user? Yeah, if you've used Vault before, you know that a default write operation overwrites anything that was here before. This is version 2. We could get version 1 back, but we've overwritten the data, so the current version is just with the token. Now, unfortunately, the Hashi Vault collection does not have patch capability, but they do demonstrate some workarounds for that using existing functionality. What you would need to do is read your secret and then combine existing stuff with what you want to add. So let's try that to get our user field back in here. The first thing we'll need to do is go ahead and fetch our existing secret. So let's start by doing that. Next, in our write, rather than adding just this data, I want to combine it with whatever already exists here. So let's go ahead and try that out. So we're going to need to make a Jinja structure. And let's go ahead and add that. And we'll get the existing information. That's going to be in result.secret. And then we're going to use the combine filter. And that's an Ansible built-in, so you can do Ansible built-in combine. And then we need to combine it with a new dictionary. Now, you can either specify this as a var and supply it here, or you can put it directly in line in Jinja. It's up to you. It's probably a little bit cleaner to put it as a var file. So let's go ahead and say values, and I'll say this time it's going to be user root at pan, because that's what we're actually adding. And now back in here, the combine filter is simply going to be values. And that should go ahead and update and add root at pan, keeping whatever is in there. So we're going to overwrite everything, but we'll just have whatever we're updating with whatever already exists by using the Ansible combine filter. So next, we will go ahead and not display our first one. We'll write it, display it after we reread it, and then display the final version. Let's see if this works to get us both our root token and our user field. Let's go ahead and run this one more time. There we go. Our user exists and our token exists. This is version 3. So although there is no patch functionality, you can work around the limitations with the collection as it exists, simply by reading, combining, and writing. If you were wondering why I didn't have to supply the token or the vault address or anything like that, it's because in this shell, I'm already logged in. I have set up my bash RC so that I have the vault address. It already knows where to find that from the environment variable. As for my token, when I did the login, it created this file, .vaultToken, in my home directory. So I already have that as well. And the collection is smart enough to reutilize that automatically. The default authentication is token, although there are other methods. This isn't a full tutorial on the Hashi Vault community collection though, so I just wanted to make sure that our vault setup is actually working, and I think I've proved that it has. Let's move on to fixing the biggest problem we have with our vault setup though. It's using HTTP. Now, it authenticated me to GitHub over HTTPS, but I set my token in plain text and sending my passwords back in plain text. Now, I'm on a local network on the same switch. Pretty low risk, but that would not fly in a real environment. We need to make sure all of our traffic to the vault is encrypted. To generate a TLS certificate that we can use to do encryption, we're going to use a collection called community.crypto. So let's go to the CLI and do Ansible Galaxy collection install community.crypto. It's going to install version 220. I want to go ahead and add that to the command line here in our galaxy.yaml file. So we'll go ahead and do that. And I'll say I want it then to be greater than or equal to this version and less than version 2.21. Okay, that should be good for community.crypto, but we also need a Python library to run this. We need the cryptography library. Let's go ahead and add that as well. We'll go to the CLI and do poetry add cryptography. Okay, that should be everything we need to use the community crypto collection. I've opened the vault task file from our Podman role. Let's create a new TLS certificate. In the create config directories task, I want to make a new directory for our TLS files. So in the loop, we'll copy paste this and update it to be our new TLS directory. Underneath our config file, we need to create a private key to do our encryption. So let's create private key for TLS certificate. To create a private key, we'll use the OpenSSL private key module from Community Crypto. By default, it creates an RSA key with 4096 bits, and that's good enough for us. So all we need to do is supply a path to the file, which is going to be vault datadir tls cert.key.pen. Okay, next we can go ahead and create our TLS certificate. So let's do that. To create a TLS cert, we're going to use the X509 certificate module, again from Community Crypto. The path to the file is going to be vault-datadir/TLS cert.pem. We need to give it the private key path, which we'll copy from our other location. And finally, we need to tell it what kind of cert provider to use. And we're going to use self-signed. This will be a self-signed certificate. This is fine for our use case, although you'd probably want something that is signed if you were making something for production. Okay, that looks pretty good so far. When we change our server configuration, we notify HashiCorp Vault to restart. Let's make sure that happens if our private key or certificate file ever changes. Rather than copying this notify to our other task, let's make a block. So we'll say restart HashiCorp Vault, and we'll create a block, and then I'll move this notify section to apply to every task in the block. Then we'll go ahead and indent our block to make sure all these tasks are part of it. So now if the server config, the key, or the cert ever changes, we will restart HashiCorp Vault. One more thing we should do is make sure that our private key file isn't world readable. But if it's not world readable, we'll need to make sure the Vault user inside the container can read it. So let's go ahead and make a notify section in here. Update TLS private key permissions. So there's our new notify block. Let's go ahead and add a handler for this. So in our handlers, we have a task that does something very similar to a want. Let's go ahead and copy that. We'll need to update the name, so let's go grab that from our notify section. Here we go. And this is a file, not a directory, so let's change the state to be file. I want the mode to be 0640. In other words, the owner can read and write, but the group can only read this file. No one else will have any permissions. Now we don't need to do a loop anymore, but let's go ahead and copy this and change the path. The path is going to be TLS cert.key.pem. We'll get rid of the loop. And also, we don't need to change the owner of this file. We want to make sure the owner is still the same owner outside the container. In other words, our Vault user outside the container. If we change the ownership to be the user inside the container, we wouldn't be able to update this file unless we did something with sudo. So let's get rid of that. But we'll keep the group being 1000 because that should still enable our Vault user inside the container to be able to have read access to our certificate key. Okay, that should be good for making our certificate. Let's go see about updating our configuration to take advantage of this. I've opened our server JSON file. Let's go ahead and remove the TLS disable of true. And let's add TLS cert file and give it the path to that, which should be data TLS cert.pem. There's going to be one more property. It is the TLS key file, and that's going to be cert.key.pem. We'll go ahead and remove that trailing comma, and that should be everything we need to apply TLS to our HashiCorp Vault. Let's go ahead and save that. One more change we need to make is in our bash rc file. So let's go ahead and open that up in Vim. And then we'll need to do an export vault skip verify equals 1. Since we're using a self-signed certificate, we won't be able to verify it, so we need to skip verification. And we'll change the vault address to HTTPS. Let's go ahead and save that. And I'll exit this. And I think we should be able to run our playbook and then use our new secure HashiCorp Vault. Let's go ahead and run our playbook. We'll run Ansible playbook, sysng quick, tutorial, setup vault. It's going to go through a few things, should be okay already. It's going to make our config directories. It made our new TLS directory. There's a problem though. it says it cannot detect the required Python library. Wait, didn't we install cryptography? Yes, but I made a mistake there. I forgot this would need to be on the remote server, not the local server, because that's what's using cryptography. So we have a couple of options. We could create these certificates locally and then copy them over, but that would be kind of annoying to make sure it's idempotent and isn't replacing the certificate all the time. So I think because we're using Fedora and we'll have a new version of the cryptography library available in the repos, let's just install that instead. So let's go up to our Vault task files and let's install the cryptography Python library. To do that, we'll put the package module, and the name is going to be Python 3-cryptography. And don't forget to become true. And let's try that one more time. We'll rerun the playbook. There we go, it installed the library. And now it's making our files. Okay, you can see it ran both our handlers, it updated our TLS private key permissions, and it restarted HashiCorp Vault. So, did it really? Well, if we look at our environment and we grep for our Vault adder, we will see that we're now using HTTPS. What happens if we do Vault status? Hey, it still appears to be working. And we know it's been restarted because it is sealed. So now we are using HTTPS. All I have to do is unseal the Vault. We should be able to use that. So let's do Vault operator unseal. Go grab my keys, be right back. Okay, now the Vault is unsealed. So can we do a Vault key value get secret Proxmox? Yes, we still can. And we have our new token ability. So can we run our test playbook? So we'll run Ansible syseng quick tutorial vault test. Does it still work? Yep, it fetches our secret. It's working just fine. So now our vault looks pretty good. Okay, I think that concludes our first Ansible project. We successfully created an nftables based firewall and NAT router and installed Podman and used that to deploy a HashiCorp Vault instance. And now that we've added TLS, it should be pretty secure. I hope that you enjoyed this project. If you did, I hope you'll consider hitting those like and subscribe buttons. It really helps out the channel. Thanks for watching. See you next time.